right, so let's prove triangles similar using angle, angle, side, 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 and side, angle, side similarity. All right, before I get into the lesson, this is a longer video, a little over 20 minutes, because I cover all three of these similarity theorems. However, if you just need a review over one of the theorems or maybe two of them, I have related shorter videos that cover one theorem each, and so I will link that at the end of this video, or you could just go on the similarity playlist and watch the shorter video that just covers one of the theorems. This video will cover all, so if you need help or you need to learn or review all three of them, continue watching this video. So let's take a look at angle-angle similarity. So that's basically if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So as an example, if S and M are congruent, so let's say both S and M are 45 degrees, and R and L are both 55 degrees, then we can conclude that the two triangles are similar using the angle-angle similarity postulate. Let's take a look at these two examples here. The first one, we see that we have parallel lines, and we know that they are parallel because they have these marks right here. So we can say that CD and FG are parallel. So remember, whenever you have parallel lines, you can automatically think about alternate interior angles, exterior angles, corresponding angles. You can always think about those angle pairs. All right. So now, since these two lines are parallel, we can conclude that this angle and this angle right here are congruent because CG would be the transversal. Trying to draw a straight line, but I cannot. So CG is a transversal, and that will make these two angles here alternate interior angles. And also these angles right here, so FEG and CED, are both congruent as well because they are vertical angles. All right, and so since we've shown that two angles are congruent to two angles in another triangle, we can conclude that yes, these triangles are similar. Similarity statement could be DEC, or triangle D, let's say DCE, is similar to triangle FGE. Remember, corresponding angles or the congruent angles need to be in the same position for your similarity statement. Let's take a look at example 2 right here. Again, we have parallel lines, right? So we can conclude that LN would be a transversal as well as ML. So let's just take a look at LN. If I extend this, and if I extend this line here, these two lines, we can see that these angles here and here are congruent because they are corresponding angles. Okay, so they're in the same position, they're underneath the parallel lines, and they're to the left of the transversal. So since we have two pair of corresponding angles, and well, one pair so far, and then right here ML is a transversal, so we can conclude that these two angles are congruent as well. So two angles and each triangle are congruent. We can conclude that yes, they are congruent using the AAA similarity. Statement that we could write would be triangle QLP is similar to triangle MLN. All right, so I would like for you to try this problem on your own and ask, are the two triangles similar, and how do you know? So go ahead and pause the video and try to see if you can prove that these two triangles are similar. So let's see if you got the problems correct, or this problem correct. R and V, those angles are both congruent because they measure 45 degrees. These two angles here are vertical angles, so they are congruent. And so yes, these two triangles are congruent by the AAA postulate. So I hope you got that correct. Let's take a look at this proof here involving the angle-angle theorem, similarity theorem. So we're given that MN is parallel to JL. So let's go ahead and write that in. Our first statement is given. MN is parallel to JL. That is given. And I'm going to go ahead and write some congruence marks here. So MN, well, not congruence marks, parallel marks. So remember, automatically you can, if you see parallel lines, you can start thinking of your angle pairs, corresponding, alternate interior, and so forth. All right, so since these angles or these lines are parallel, do we have any congruent angles? So yes, because KL would be a transversal, all right? So KNM would be congruent to KLJ because they are corresponding angles. So we can write that in. Angle KNM is congruent to angle KLJ because they are corresponding angles. All right, and then we could also conclude that KMN is congruent to KJL because again these two lines are parallel, so angle KMN is congruent to angle KJL. All right, and again those are corresponding angles as well. And so since we have a pair of congruent angles in each of these triangles, we could say that triangle JKL is similar to triangle MKN because of the AAA similarity postulate. All right, so we have a proof here that I would like for you to try on your own using the angle-angle similarity theorem. So try to fill in numbers 2, 4, 5 in the statements and 3 and 6 in the reasons. So go ahead and pause the video and try this proof on your own. All right, so for number 2 here, you should have mentioned that these two triangles are isosceles, meaning they have two congruent sides. For number 4, F and J are congruent, and that is given. H and L are also congruent by the transitive property, and therefore these two triangles are congruent by the AA postulate. All right, so let's take a look at using the side-side-side theorem to prove triangles similar. The side-side-side similarity theorem states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So as an example, let's say each side here, this was 2 over 4, this was 3 over 6, and this was, let's say, 6 over 12. All of these sides reduce to 1/2, and so they're all similar, and that will make these two triangles proportional. Let's look at these two examples here. So the first one here, example 6, we have a smaller triangle within a larger triangle. So the first thing you want to do is figure out the length of the sides of the larger triangle here. So the length of WY would be 15 plus 6. So the length of this side would be 21. And so WU, the larger triangle, we add 20 plus 8. So the length of this entire side is 28. And so now we want to set up fractions or proportions to see if they reduce to the same thing to see if this triangle is similar. All right. So I'm going to start out with this side right here, WY, or WX over WY. So the smaller triangle, I'm putting it in the numerator, 15. The larger side, or that larger triangle side, is 21. And I'm going to reduce this fraction. They're both divisible by 3. So that reduces to 5/7. All right, looking at this side here, 30 over 42. 30 divided by 42. These are both divisible by 6. So that reduces to 5/7. And next, the last side here, we have WV over WU. So that would be 20 over 28. Reduce that. They're both divisible by 4. So we're just reducing the fractions here. And they all reduce to the same thing, 5/7. And so these sides are proportional. So yes, we could say that this triangle or these triangles are similar using the side similarity. Next, let's look at this one here. We have our larger triangle and smaller triangle. So let's set up some corresponding fractions, or a fraction using the corresponding sides here. All right, and so we have our smallest side, so that would be 5/4. That does not reduce to anything. Our middle side would be the 12 and the 7. So that would be 12/7. That cannot be reduced. And I can actually stop here and say that these triangles are not similar, but I'm going to keep going. So the larger sides here are 16 and 10. And we can actually reduce that to, let's say, 8/5. But it does not matter because none of these reduce to the same thing, right? And so we could say that these two triangles are not similar, or we could use this symbol here for similar. All right, so I have another problem for you to try here. Example 8, it asks, are the triangles similar? If so, write a similarity statement for the triangles. And remember, with the similarity statements, the corresponding sides have to be in the same position. And if you need some help with similarity statements, please refer back to the video I have on similar polygons. So go ahead and pause the video and go ahead and try this one on your own. All right, so these two triangles are in fact similar. Each ratio or scale factor reduces to 2/3, and so they are similar using side. And this is our similarity statement down here. You could have it set up differently. You could have triangle UTS is similar to WVX as long as those corresponding sides are in the same position. Let's look at proving triangles similar using the side-angle-side theorem. The side-angle-side similarity theorem states that if an angle of one triangle is congruent to an angle in the second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So we're looking at these included angles here. So angle A and angle Q are included, they are congruent. The sides have to be proportional as well. So as an example, let's say this side was 4, AB, and this side was 10, and AC, let's say that was 6, and QS is 15. So AB over QR would be 4/10. That reduces to 2/5, right? And then AC over QS, that is 6/15. That also reduces to 2/5. And so those sides are proportional, and so we could say that these two triangles are similar using the side-angle-side similarity theorem. Let's take a look at these two examples here. So example 9, we could already see that these two angles are congruent, and we know that because they are vertical angles. So we already have an included angle there. All right. And so next, let's look at our sides here. So our shorter sides for each triangle are side 6, or has a length of 6 and 24. So that is FE and ER. So we can write that as a fraction, 6 over 24. And let's go ahead and reduce because we can, and that reduces to 1/4. Our larger sides are 12 and 48. 12 over 48 reduces to 1/4. All right. So the sides are proportional, and we have those included angles that are congruent. And so we could say that these two triangles are similar using the side angle side theorem of similarity. And let's go ahead and write a congruency statement. So FE, I could say that triangle FEG is similar to triangle RES. All right, and so we could see that those corresponding sides are actually in the same position. All right, so now let's look at the second one here. So we have a triangle within a triangle. So this side here would be 39, side GL. Side BL would be 7 plus 27. That's 34. So I'm just adding these two to get the size of that larger triangle. All right, we already have an included angle here. So those two angles are congruent because these two triangles share an angle. But let's see if the sides are proportional. So if we're looking at this side here, so our shorter triangle has a side length of 27, and that longer side, or that larger triangle, has a side length of 34. And then right here, our other side, GL and XG, or GL and XL, I'm sorry. And so the length of that smaller triangle would be 30 over 39. We can't reduce them, right? So we could see that these are not proportional, and so these triangles would not be similar. So although they have an included angle, they are not similar because the sides are not proportional. I have a problem here that I would like for you to try on your own, and it asks, are the triangles similar? If so, write a similarity statement for the triangle. So go ahead and pause the video and try this problem on your own. These triangles are in fact similar using the side angle side theorem. All their sides, or the two sides, are proportional. They reduce to 4/5. And the included angle right here, so we can see here and here, they are congruent because they share that angle. And so since the sides are proportional and the included angle is congruent, we can conclude that these two triangles are congruent. Hope you got the problem correct. Or these two triangles are similar, not congruent. So I hope you got the problem correct. So now we have a review over the entire, or all three theorems, the angle, side, and side angle side similarity. And we have two examples for each one. I would like for you to pause the video and try these on your own to review over each one of these theorems. So go ahead and pause the video and try these on your own. All right, so just to review the angle similarity, if you have two angles congruent in each triangle, then those two angles are similar. So for the first one here, we got yes, they are. And the second one also yes, because you have vertical angles, and they also have a pair of congruent angles right here as well. All right. Next, for the side angle side, the first one is a yes, because if you reduce each one of these corresponding sides, for example, 3 over 6, so that is the shortest sides for each one, they reduce to 1/2, all three sides. And so they are proportional, so yes, these triangles are similar. If we look at number 4, looking at the smallest side here, 30 over 24 for each one, and then 32 over 25, and then 35 over 28. They do not reduce to the same thing, and so no, these triangles are not similar for number 4. Number 5, we have an included angle here, and so the two sides, the smaller side, 8 and 6, and 20 and 15, they both reduce to 4/3, so they are proportional, so yes, those two triangles are similar. And for the last one, that would be a no. 15 over 12 and 25 over 21 do not reduce to the same fraction. All right, so hopefully you got all of them correct. If not some of them, it will help to go back and review these, maybe pause this screen to review a little more if you did not get them all correct. All right, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are similar polygons and the triangle proportionality theorem. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.